Okay, the next one gives us a series here, and they just want us to find the explicit rule for the sequence, which is 1 over, in this case, 4 to the nth power, because the first one gives you 1 to the 4th, the second one gives you 1 over 4 squared, third one gives you 1 over 4 cubed, which is 64, so that works for the rule. So just 1 over 4 to the nth. Okay, the next one wants to find these partial sums. The first two would be adding up the first two, 7 over 2 plus 7 over 6, which you could do in your calculator quick enough. It gives you about 4.6 repeating. The next one I want you to add up the first 4 terms, so I don't even have the 4th term. So for that, I'm going to write a rule for this, which is n times n plus 1 here. And I'm going to add up then sum of n equals 1 to the 4th term. Just plug this into the calculator. To do that, once again, we go to alpha window and hit 2 and then type this in. I'm going to use x instead of n, and that gives you the answer, 28 over 5. And then if you want to find the next one, the easiest way to do it is just change one of those to 6. So just go back up and grab this and just change this top number up here to a 6 and hit enter. And that gives you just 6. Okay, the next question says an auditorium has 41 rows of seats. It says the first row contains 90 seats, and as you move rear of the auditorium, as you move to the rear, each row has 3 more seats. So the next one's going to be 93, and so on. Okay, this is an arithmetic sequence. So I'm going to write the explicit rule real quick, which is 1 plus n minus 1 times the common difference. The first term is 90. The common difference is 3. I can simplify that a little bit if I make it 3n plus 87, which is what I get when I distribute and add like terms. So then when they want me to find how many seats are in the 38th row, just plug in 38 for n right here. That gives me 201. And then they want to know how many seats are in the auditorium. I'm going to use the sum for that. I'm going to add up the first 41 rows, because that's how many there are total, of this sequence, 3n plus 87. Okay, this will work if you do it in your calculator, or you can use the formula off the formula sheet, which is the number of terms, first term plus the last term divided by 2. So there's 41 total. The first row there's 90, and then the last row I need to figure out what that is. So I have to plug in 41 into my rule, 3n plus 81. So it'd be 3 times 41 plus 87. That tells me how many seats are in the last row, which is 210. So that goes right here. If you do that in your calculator, you get 6150. Okay, the next problem is one we're just going to plug in the calculator again. So just pull out your calculator and plug this in. We go to alpha window and hit 2. And I get 38,092. Okay, the next problem gives us an arithmetic. It says the 9th term is 5, the common difference is -2. So here's my table. We don't know the first term, but we do know the 9th term is 5, and we also know the common difference is -2. So we want to find the first term. Well, I'm going to use my formula, a sub 1 plus n minus 1 times the common difference, and I don't know my first term, but if I plug in 9 for n, the common difference is -2. I know I'm going to get 5, so I can plug in everything I know and solve for a sub n. So that's 8 times -2, which is -16. Add 16 to both sides, it gives me 21 for a sub n. So the first term is 21, and then if I add the first 45 terms, what I can do is go ahead and simplify my formula for a sub n first, which is right here. This gives me 21 plus, distribute the -2, you get -2 plus 2, -2n plus 2, which gives me -2n plus 23. So there's my sequence. So what I'm adding is the first 45 terms of this. Now I could use this formula once again, but I'm going to go ahead and just plug this into the calculator. That gives me -1035. Okay, this problem gives me this sequence right here, 6 over 3n, and they want us to find some sums. So the fifth partial sum, and then the nth partial sum. So this is a little bit of a tricky one, but I'm going to rearrange this. So I'm going to make it 6 times 3 to the negative n, because I can make it, negative 1 to the nth basically. 3 to the negative 1 is 3 in the bottom. So now I'll make this 6 times 1/3 to the nth power. So this 3 to the negative 1 can be rewritten as 1/3. So this is the same thing as that, just written differently. And now you can see that's a geometric sequence, because my geometric sequences are g sub n equals the first term times r to the n minus 1. So it's got that pattern right there. I know I'm using n now instead of n minus 1, but that's not a big deal. So my first term is what I get when I plug in 1 here. So 3 to the first is 3, so that'd be 2. My first term is 2. My ratio is 1/3 to the n minus 1. So here is the explicit rule for the sequence right there. I can use the formula off the formula sheet if I'd like to find the sum of the first 5 terms instead of just using the calculator. So finite geometric series, the formula is right here. So the first term is 2 that goes in for a sub 1. Common ratio is 1/3 to the nth power, so that'd be the fifth power over 1 minus 1/3. So I can do this in my calculator, simplify that, or I can just plug in this to find the first 5 terms. Either way, you get. Okay, so if we're going to do the nth partial sum, we actually have to do this, and we have to plug in n for 5, because we don't know how many terms we're adding up. So we are going to have to simplify that right there. So let me take a look at this expression. And by the way, I get 242 over 81 for a. But to simplify this now, in the bottom, I'm going to make this 3 over 3, so there'll be 2/3 here. And then I'll multiply by the reciprocal of that, so I'll multiply by 3 over 2 times 2 times this quantity, 1 minus 1/3 to the nth power. So the 2's cancel here. I get 3 times 1 minus 1/3 to the nth power, and that's probably how you're going to want to enter it in right there, but that should work. Okay, the next problem asks, is this sequence arithmetic? Yes, I'm adding 3 each time, so the common difference is 3. Next one, same question, and for me it is yes, and I'm subtracting 1.5 each time, or negative 3/2. Next question says, is this series arithmetic? The answer should be no, so I shouldn't have to fill this out. If you start to write out these term numbers, you'll see the first term is 1/9, second term is 1/16. There's nothing you can't add any number each time to get to these different terms, so it's not arithmetic. It's only arithmetic if you're adding a common difference each time. Okay, the next problem, the last problem, says determine whether the sequence is divergent or convergent. It is divergent, as you can tell. As you plug in a bigger n here, eventually this is going to go to 0, because you're dividing by a really big number here. So that's going to go to 0, but you still have this term, and so it's negative 10 times whatever negative number you have. So you can tell eventually this thing is going to go off to negative infinity, and that says if it diverges to negative infinity, which it does, enter in m, I, and f. So all capital letters, that should work.